Hello and welcome to Forward. Our guest today is Amit Ben, the CEO and founder of OneAI. OneAI is an API first language AI service built for developers. Their product ready APIs, no code language studio, and vertically pre trained models allow every developer to deliver the power of NLP inside their applications in no time. Amit's passion for language technology started at age 5, coding on an XT machine. Since then, he's been on a mission to make language AI accessible to all. Amit co founded NanoRep, sold it to LogMeIn, and then joined the company to lead the AI lab, developing the AI tech that powers products such as GoToMeeting and LastPass. When Francisco Partners acquired LogMeIn, it was time to hit the entrepreneurial road again and continue to fulfill his mission to make language AI integral and natural in everyday life, founding OneAI. In this episode, we talk about the evolution of natural language processing, the impact of the transformers on the field, the challenges of building enterprise ready AI systems, and the importance of understanding the limitations of modern AI when applying it in critical areas. Amit, welcome to the show.
Thank you very much.
Let's start with an overview of the field of natural language processing. What it is, how has it evolved over the years, and what's the current state?
Natural language processing is the story of human beings trying to teach computers what it is to be a human. And technology started a long time ago with different user interfaces that were completely unintuitive for humans. And we, as people, had to learn how to operate these machines. And that's humans adapting to a machine language. And over time, when we got sophisticated enough and we started developing technologies that can understand human language, even in a very rudimentary fashion, we started a journey to have machines started adapting to us. So the computer interfaces are starting to be more human-like instead of the other way around. So I can tell my Alexa or my Google Home to do a task, and I can use more or less human language freely. And the more this technology evolves and matures, the more natural that we can be, the more all-encompassing the understanding of computers of human language is, and the more types of use cases we can do. While at the same time, we're reducing the barrier to entry and reducing the work that needs to be done to make something work. And I think we need to be very careful when we say natural language understanding, because there's no proof yet that machines are actually understanding what we're saying. They're predicting the outcomes of certain speech or certain text, and they can devise some output from it, but it does not actually mean they understand. We need to be very explicit when we talk to machines. And I think for me, the vision of natural language processing or language AI is to get to a place where we can actually get to that precipice of real understanding, that we don't need to think about how we say and what we say, and actually have products react to us in a natural way that is not prescribed.
We do go further and further on the road to be able to control machines with natural language. And actually, I've been thinking about the future of that and when we will have the first machines. And then, as you said, we already have Alexa and we already have Google Home. But I also thought that the very first application probably is Google itself. It's the machine that we control with language, and it's been around for a decade. So it gives us a very good glimpse into what machines controlled by language can do, because it's quite powerful, Google itself, and that interface that you just type whatever question you want into Google. But it also has quite a bit of limitations. It not always gives you the right answer. It not always can understand what you mean with your language. And you need to do a lot of work after you get the list of answers. You need to curate them and you need to search through them. So it's always a fuzzy result. It's always incomplete result.
I think when we look at Google or search engines in general, search engines did a real nice trick where they actually trained us to phrase ourselves in a manner that is conducive to the behavior of the search engine. And they did a really good job. And I think most people today have learned to communicate with search engines. It's like a certain flavor of English, I would say, that is designed to communicate with search engines. And again, as you say, you try not to be too descriptive, you try to be a little more explicit, and then you're going to get a list of items that are hopefully around the topic you're looking for. And then you need to do your job next, which is the actual understanding of the content. In some cases, it works amazing. In some cases, less than so. And especially when you look at extremely large scales deployments like Google search, it's much harder to leverage the state of the art in natural language processing because of the processing power required to actually utilize the state of the art machine learning models, because they are extremely prohibitive from execution standpoint and resources standpoint. And especially if you want to search the data, it's not only understanding the query of the person, you need to do all of the analysis on the entire scope of human knowledge in the internet if you want to get a good result, which I'm not sure is even feasible with today's state of the art technology. So there's still work to be done there.
About 4 years ago, with the Transformer paper, we got ourselves large language models and many other things. But speaking about large language models now, what do they bring to the table for the NLP field?
I think transformers, brought a transformation of how we look at the natural language processing, and specifically, they enable transfer learning in the realm of natural language that allows us to take a machine learning model and pre-train it on general data and general knowledge. So when we bring it into a specific task, you want to train it, for example, on identifying complaints in a customer service email, it does not need to learn everything from scratch. It also has a good grasp of the language in place. So it just learns that specific task. And transfer learning has been available for a very long time in machine vision and in other spaces of machine learning. We also had ability to do transfer learning with word embeddings and sentence embeddings for quite a while, but they're not as powerful because the ability to embed large bodies of text was not able to do so. And we could also not train on very large amounts of data. And we would start lose information as we train on very large data sets. So what transformers brought to the table is the ability to create very large models that are able to train on huge amounts of data while retaining a lot of the data in them, and then enabling us to do all sorts of tasks that we did not initially train for. And that allowed machine learning researchers and engineers to take the next step and actually start from a model that has a good grasp of the language, and then take it from there and then start creating things that do specific tasks. And transformers are a great technology. I don't think they're a cure-all solution. They do have a very, very important role in how we do net language AI today, but they're only a part of that solution.
I wonder what kind of parts do you see we're still missing there? What kind of use cases is NLP a great fit for right now? And what use cases still need more progress in NLP to become feasible?
Large language models have a lot of advantages, but they also have some disadvantages. For example, if you ask GPT-3, you ask it, who's the president? It'll say it's Donald Trump. And that is just one example, exemplifying how large language models has a problem of being very hard to maintain and train because of their size and the cost goes into training them. So there was a very good recent paper of leveraging knowledge systems combined with transformers, so the knowledge remains fresh, and that's still something that we need to solve for. Also, specializing large language models doesn't always work very efficiently. It's very cost prohibitive if you really want to do some specializations because of their size. And finally, because large language models are so large, there's still problem of retention and fit to the data that they've seen or not seen. And because all of that data is embedded in their parameters, it's a bit unclear how much of their output is a function of understanding the text rather than being a very, very strong statistical model that statistically hits very well the outputs. But if you give it inputs that are a bit contradictory to what it has seen, it does not handle it correctly. And there are a lot of examples there also. The GPT-3 papers themselves show a lot of examples where the models keep going back to the resources that they've trained on rather than assimilating new data. And there's a lot of work being done to improve upon these different components and, and deficiencies of large language models. But we're making headway and things will improve over time. And talking about use cases for language AI, that's a completely separate question from language models, because we can solve a lot of use cases that each individual technology does not solve inherently automatically. And that's the job of language AI researchers and companies like One AI. Our job is to take the existing technologies, take the next steps, and train those systems and also make use of engineering capabilities to solve different use cases. And we can solve today a vast number of use cases with the current state of the art technology, but in differing levels of investment. So some use cases are just easier to solve for than others. It's also a factor of the availability of data and how much the data is explicit or implicit, or how much are the concept very abstract or very concise and easy to grasp.
I think we will go into more details about the use cases that you guys power in a second. I'd love first to talk about the goal and the purpose of One AI as a platform. You've built it to help developers integrate NLP into their products. Why do you think it's important to democratize NLP? And why did you choose to do it by empowering developers?
When we look at any type of fundamental technology out there that's powering products and providing business value and consumer value, there are phases in the maturity of that technology and steps to make that technology come into the hands of consumers and business users. And initially, the process is a research process. It's a learning process. We develop the technologies, but finally, ultimately, engineers are the ones that are building those products and building the world. And when we take the fundamental capabilities of understanding language, which I could say is probably one of the most fundamental problems, full stop, in human technology. It's the most fundamental technology, full stop. Empowering engineers with the ability to create things with that technology, I think will unlock the most value to the world possible. And as long as we keep those capabilities in the hands of special few, in the hands of PhDs and research organizations and large enterprise companies, we're not enabling human culture to evolve and harness this technology at scale. So, finally, combining the simplicity of using this technology and to provide the power to leverage it easily is going to drive a new wave of innovation.
What are the key capabilities of the platform? And how do you define the persona beyond that it's just developer? Is it any developer, or there is some group that is the best fit for One AI?
Yeah, so first of all, definitely any developer. The One AI solution is platform agnostic. It's also mostly domain agnostic in terms of the value proposition. But if you know how to write one line of code, you could use One AI in 1 minute and probably deploy your first AI, state of the art language AI capability extremely easily. And if you're a product manager, you can also use our platform to experiment and visualize language AI skills and capabilities on your data on our no-code language AI studio. And the goal was to solve for the key challenges of leveraging language AI. I think the first challenge is awareness or imagination. What is possible to build with this new breed of technologies? What can I build with the readily available capabilities? And what can I do without a very long, 2 year long research process? And for that purpose, we've built the language studio that allows anybody, whether they're an engineer or a product manager or a business leader, to experiment and try to visualize and broaden their horizons of what is possible to achieve with these types of technologies. So that's the first part. The second part is, so the first part was to create awareness and exploration and make it approachable for anyone. The second part is to actually package the technology in a way that's very easily integrated into any product. And there are multiple, when I'm looking at One AI, there are multiple challenges that we're solving for our customers and for engineers. So if you want to get the language AI capabilities into your product, the first thing you would think about, okay, I need to find the model that actually solves the problem I'm trying to solve. Either that's starting to read research papers or looking online in open source repositories, or just crawling the web and GitHub to find a solution that already works. For that, you should probably have some PhD training in reading those research papers, or you're going to do a lot of trial and error. But eventually, in most cases, you would have to train your own model. And the job to find or train that model is the step one of what we solve for. The next step is to measure, is this actually working in a way that is solving my problem and I can rely on it to do it in a good enough quality in my product? And training and collecting data, and forget even about collecting data to train the model. Let's even assume you find a model online that supposedly does the job. How do you measure that for your data, for your use case, it works? So One AI also curates and collects benchmarks for business use cases, and we measure and we make sure that when we provide an API that reps an AI skill for you, we've already done the measurements and we know we're providing you the best possible solution to solve for it. So that's part two. Part three, assuming you found the model or collect the data and train the model, and then you also were able to measure the model and you're satisfied, now starts the engineering journey of deploying it in production, the engineering required, the ML ops required, and building all of that infrastructure, which is not as mature as other cloud services, which are much easier to deploy today. So all of that operation is something that you would need to solve for yourself. So these are the three main components that we will take care of for you. So you have an API that is accessing a robust production ready engineering deployment environment that has all of these capabilities already deployed in highly scalable, highly performant environment. And behind each of those APIs, there's a model that's been trained to solve in very high confidence and quality the problems that you need solved. So our job is to curate and find the key problems we're solving for our customers and make sure they're deployed in production. And usually that does not end with an open source model, unfortunately. And we can discuss that in a minute.
And we will. But before we go into that, let's give our listeners a quick overview of the capabilities of the platform. What I, as a developer or as a product manager, can do with One AI. I did play with your studio, and I should admit it's definitely one of the easiest tools for NLP.
I'll give a broad overview and see if I can cover most of the capabilities in the platform. From the standpoint of input, we can allow developers and product leaders from many domains to input their data into our platform and process it and get the output that they need. We support any type of language input, whether that's text based or audio based or image based. You can also input your audio files or meeting recordings. We support written text like articles, blog posts, and we support conversations like the one we're having right now, podcasts, webinars, sales meetings, sales calls, phone calls, and so on. So you input your language input to the system, and then you select the skills you want to apply on them. And one of the core tenets of our platform is that all of the language AI capabilities are stackable and composable, meaning you can execute them in different orders, in different sequences, and get the results that you need. So, for example, we have skills to proofread text, to split it by topics or by sections. You can cluster text, you can classify it, you can extract data points, and you can mix and match in different ways. So, let me give you an example. You could, for example, take an email thread, a conversation in an email thread, and you would split the thread by topic. You would pick the section that is discussing pricing information, and you would extract the emotion of that section. So multiple skills applied in a sequence, and then finally you get the emotion the customers had regarding the pricing information. Or you would take podcast, you would split the podcast into different segments, you would create a headline for each of those segments and a quick summary and highlights, and you can allow users to navigate it very easily. Or you can identify action items from a call and identify the time and date for the next action item to occur and put an invite in the calendar. So you can mix and match between 22 different skills right now. And we keep adding more skills and also training the skills to work on different use cases. And one of the, I think, the most important capabilities that we have is that when you put in some content into our platform, it could be a sales conversation, a customer service email, or a blog post. And the platform automatically identifies the domain and would execute the right model that fits your use case. So if you're trying to summarize a sales call, we would execute a model that was trained on summarizing sales call. And if you're inputting a blog post, we would execute a model that's trained to summarize a blog post, and so on for all of the other skills. So that makes sure that we're completely solving the problem for you without the user needing to think about which model I'm using for which use cases and which data I'm trying to extract. Think about it very similarly to a voice over IP platform. When you integrate with a voice over IP platform, it does all of the identification of your connection speed and your device automatically and chooses the right compression algorithm. And that's their job, right? Because they're the expert on compression algorithms. And the promise of One AI is that we're going to continue to evolve the offering and expand the variation and the flavors of models for different skills per different domains over time to make sure you always get the state of the art for each skill and each use case. So that's actually one more problem we're solving for our customers. You don't have to keep your eye on the state of the art all the time and updating and maintaining it, because that's our job. So we have one job to make sure for every skill in every domain, we provide the state of the art of what's possible, regardless if it's open source or proprietary or an academic paper implemented.
Let's try and make it more tangible. Say I'm a developer and I'd like to implement an NLP use case. For example, I have a sales email thread and I'd like to extract entities and I'd like to understand the sentiment, the customer's sentiment about the price. And let's say this thread is in healthcare, so it's a domain specific one. And I'm a developer, so what are my steps from that idea that I want to do that to the final running product in production?
We try to avoid terms like do entity recognition because nobody wants to extract entities. They want to extract specific entities. Like you might be interested in the names of the people on the thread and their titles. You might be interested in the names of the companies, or you might be interested in the product that they've purchased or are looking to purchase. So in our skills, you would select what you're trying to identify, and you can say, I want to identify names or products or places, and we would extract that for you. And the example was a sales email. You want to get the entities and
Let's say it's a sales email and I would like to understand the other companies mentioned there.
yeah,
And I would like to understand the customer sentiment about the price point.
you would use a few of our skills. First of all, you would use our sales insight skill that has built in a detection of competition mentions, customer needs and features, and who's the authority and timing of the deal. And you get that as data extracted from the email thread. And you would also use the pricing skill that extract pricing information, and it will highlight in the conversation where pricing information was mentioned. And you would use the emotions skill or sentiment skill, and I'll give a little more color on that. So you would use these skills to figure out what does the customer think about the pricing information. And when you use the emotions and sentiment skill, first of all, these are things that we differentiate between. Sentiment is something that's a little bit abstract and not all that much useful usually. It's a little bit vague. I can say, thank you for the pricing. That's immediately something positive, but there's no real information there. Yes, I got the pricing information. That's also a positive sentiment. It's just something that I'm saying that's a positive indication. But again, I'm not learning anything about the pricing compared to what we have in our platform, which is emotion detection, which is a lot more explicit and powerful, is say, thank you for the pricing. It's good. I like the pricing. It's great. Thank you very much. Or I'm not sure that pricing will work for us. And that would be identified as sadness, right? And those are a lot more explicit in the terms of what is there an emotional reaction and an opinion on something that happened rather than just being positive or negative without any context. So you'd use that and see where the emotion intersect with the segments of text that has pricing in it, and you can infer from that what is the customer's emotion regarding the pricing. And all of that you do off the shelf with a single API call. So in the API call, you provide the input, which is your email thread, and the parameters for the API call would be the list of those skills that you want to execute. So it could be the sales insights, pricing, and emotion in this case. And the output would be a nice JSON structure breaking down the conversation with all of the elements you've requested.
So there is nothing more to do there. Just integrate this API call into your product and use it in production.
And the API is already production grade with all of the necessary security and scaling capabilities. So the idea is to allow developers to really experiment and really move fast with integrating these capabilities and allow them to focus on their product and their business value. And the downside here, I think, is that we don't have a solution for anything and everything. So we try to prioritize the capabilities that would provide value to most developers, and over time, we'll create more and more capabilities. There's already a very big variety of skills, and the combinations also allow for a variety of use cases to be solved for. But we still have our work cut out for us in expanding that further and further.
And if my domain is quite specific, like healthcare or something else, where we need to operate with specific terminology, do I need to fine tune the models or how do I approach that specificity?
One of the core concepts of One AI is that you don't need to tune models or train them. That's our job. And we try to, and being an engineer, that's really something that's unintuitive. So how do you train when you specialize? How do you know that you've made it better or overfit it to your data? And you need to know exactly the behaviors and the statistics of each model individually to gauge and even get intuition whether or not you've done a good job or the model is robust enough. So that's mostly our job. In, for example, in healthcare, we currently don't have skills, so we try to focus on other domains for the time being. So mostly sales, customer service, social interactions, content marketing, and media. We're going to add additional domains as we go forward. We do allow for what we call custom insights training, which is allowing our developers to leverage the platform that we've built to give us examples for insight they were looking for in the text. And our platform does something similar to AutoML, but a bit different, and basically takes the model and does few shot learning to identify core insights. So if you're looking to find maybe from an email, where's the I don't know where is the prospect based? Like I'm based in Tel Aviv, and maybe someone else is based in San Francisco, and that's something you want to capture. So you can give a few examples for that, and we would run it on our platform and base it on domain specific models behind the scenes as well. So it's not trained on a generic large language model. It's trained on models that are specialized for these types of data points in customer service or in sales or in marketing and so on.
This sounds like a powerful function to show the platform what kind of information you're looking for and be able to teach it that way. How do you define or measure the success of your users in implementing the APIs?
So right now we're highly focused on adoption. So our goal is to get as many developers on our platform, and we measure the time to value. So how fast were they able to deploy, and how many errors or difficulties they had along the way. And that allows us to measure, are we being explicit enough? Is everything as simple as it could be and robust enough to handle whatever developers throw at us? And it also speaks to our core value in the company. We set the core value, we call it, it should just work, as opposed to transferring our problems to developers. And you can see that in various NLP platforms where you give developers 20 different levers they can mess around with, and dials and values and parameters. And it's hardly the job of an engineer working on a product problem to figure out what's the right temperature or p-value for generating a response for classifying a product review, right? That's our job. That we're not transferring that to our developers, and we tune everything for our customers. So it should just work out of the box. And we have a very large library of solutions behind the scenes that we keep improving and tuning, so you can focus on your product. You do you, and we'll make it just work.
And when you talk about time to value, what kind of time to value you guide your customers toward? What should they expect?
From the language AI standpoint, we have a lot of customers that were able to onboard in minutes. I would say 30 minutes. We had somebody complete an integration because they already had whatever they needed in their product and the user interface. So they just plugged it in and it worked. It was a couple of lines in Python, and they got the value that they needed. Specifically, I think it was summarizing the customer service interaction and identifying key points in it, like emotional pieces and the highlights from it, and present it. And we have other customers who needs to do a lot more in-depth work in weaving the value into their product offering. So a lot of the time to value is mostly dependent on the offering on the product side. So how complex is the user interface that you need to build? How complex is it to build it into your pipeline and framework and bring the value to your customers? Some products are there in terms of the packaging, and some products are coming up with completely new ideas that require a lot of work. Maybe they need to open a new section in their product. For example, one of the things you can do with one AI is to create language analytics capability to analyze your entire contact center or sales center. And we've worked with a product that didn't have any analytics in their product at that point. So they wanted to leverage this capability, but that mandated that they needed to create a new section in their app and transfer all the data and create all of the user privileges for that. And it was a broader project. So that's usually the gating factor for the time to value. Because when you find a skill that we have, it's already deployed, it's already working. There's no natural language journey. There's no research process. You don't need to collect data and measure stuff. You just plug into the API and it works.
You mentioned summarizing customer service conversations. What are your other favorite examples of one AI implementation by the users?
Oh, we have some really cool ones. And I mostly like the ones that we didn't foresee. There are the obvious ones that we have constantly thought about in terms of customer service and identifying cases and tickets and finding recurring issues. But I think the ones that blew our minds when we saw them was, for example, a company that have built a Reddit research tool that is using one AI in behind the scenes to analyze Reddit threads and find key topics that are mentioned and summarizing all of the correspondence in those threads and providing a digest and a research tool for that and providing positive and negative comments on these topics so you can very easily see the discourse around these topics. That was really cool. Another company has built an AI based video editing tool based on one AI. So you input your video, and if you want to edit it to create a YouTube video or a trailer, you put your video in and you split the entire video content. You can put video input into one AI as well, and it would transcribe it all. And then you can sequence all of the other skills on top of that. So the input is the video, it's being transcribed. You split the video into different topics. You get the heading for each of these topics and the highlights and the emotional highlights of all of the video using the emotions scale. And based on that, the user can click on these elements and just kind of check the ones that they like. And based on that, edit a quick trailer for that video. And it's all AI based. So I would have never imagined we would power a video editing tool that works like magic. And it's really impressive to see that these guys did a brilliant job wrapping that together.
The Reddit research tool sounds like something I would use. I yesterday spent some time looking at the conversations between the artists on Reddit about the generative AI and how it will affect their work. And there's a lot of going on there and lots of different opinions.
Yeah.
And I'd love to be able to use some help to get to the summary of those opinions.
Yeah, you see, I think it's really cool seeing that the trajectory that AI is heading towards. If you look at it from 10,000 feet, you see that most capabilities out there that are maturing are focused on generation. Like you generate text, you generate a haiku with GPT-3 or a Picasso drawing of a dog drinking champagne in Dali, right? And that's really cool. And it does impact some jobs or some tasks. And they're doing a great job. And by the way, in some respect, it's extremely hard, but in other respects, it's a little easier because you cannot draw a wrong picture of a dog drinking champagne, right? So it's a different criterias of success. And if you don't like it, you just generate another one. So the benchmark is a bit different here. But I don't think that generating new data is humanity's problem. At least from our perspective, businesses and product companies and even individuals, we have so much data. As you said, you just wanted to review that Reddit thread. If I would have told GPT-3 to generate a new Reddit thread, that wouldn't help at all, right? You want to basically take the data that there is and condense it down and extract information from the data. And that is what One AI is all about. We're not focused on generating more out of nothing. We're actually focused on generating less, but highly valuable information. So you have a conversation, we can give you the summary, but the summary is representing a part of the entire conversation. It should not generate something that wasn't there. But which, by the way, is the core problem for generative AI models that create summarizations. They make mistakes. The technical term is hallucinations. And that's one of the core problems. We want to be faithful and maintain correlation to the original data when we create that.
You're right in the sense that I definitely don't need more data flooding my brain. I do need to be able to process the data we already have. Among those examples that you brought up, you also mentioned there is a customer who is building the whole new section in the product to power analytics based on one AI platform. What is that set of analytics capabilities that one AI can provide?
We've discussed all of these different skills that we have that allows you to take an input, let's call it one data point of input. It could be one conversation, one email, one document, one email thread, and extract all the data from it, all the information. Now, what happens when you want to move from one data point and now you have a million emails or 100,000 sales calls or email threads or Reddit threads you want to process? And that's where the One AI language analytics platform comes into play. As part of the processing pipeline, you extract all the data, you do all of the processing that you're interested in for that data point. So, for example, we'll take a blog post, you want to get the companies and the people mentioned and the topics and the highlights, and then you push it to the analytics platform that give you an aggregated view of all of the data of all of your data points in different dimensions. And the dimensions are all of the data points that you can extract from any of our skills. That includes informative data points like numbers, people names, times, companies, location, and so on, but it can also be meaning based. So if you extract the complaint from all of your customer service emails, you would then see an aggregate view of all of the different complaints grouped together by the complaint meaning, by the topic. So you can see all of the complaints about products coming in the wrong sizes or different colors or being broken and so on, grouped together, regardless of the way they've been phrased and expressed. And you can zoom into that different variations and zoom in and zoom out and slice and dice on all of the different dimensions. And that really empowers companies to deal not only on individual to individual data point basis, so just look at one email and get data from it, but also derive information from broad data sets and that are sometimes business encompassing.
The individual cases sound more like what you will build into your day-to-day workflows
Yeah.
of your product, operational part. While the second piece is about taking a step back, looking at the whole picture and overviewing your whole set of data collected in a easy to digest way.
Yeah, and in some point there's some connectivity and interoperability there. So if you're clustering all of your complaints or needs and features and product requests and competitors from sales calls, and you can identify those in the analytics system, you can also query them in real time to identify, oh, have we already seen this complaint? Have we already seen this need or customer request? Have we already seen this competition mention? And then pop up the required information for the user. So you can use it as a classification engine as well to find the right data. And you can also use all of the data points as a sort of data enrichment for your database. Maybe you have a document DB or relational DB that you store all of your conversations in, but it's unsearchable. You cannot query it for somebody's name because it wasn't mentioned in a very specific way or a product or a need. And when you execute all of different skills, you can save that metadata, you can store that metadata with your document, and then now everything is queryable on all of these dimensions. So there's kind of reciprocation between the long-term and short-term capabilities of both capabilities. And we try to leave that to the imaginations of engineers, which I'm sure are going to do things we have not thought about.
That's usually what happens with every new technology.
Yeah.
What are the main pitfalls developers encounter when integrating NLP capabilities into their products?
I think it's the pitfall of integrating any deep technology. So if you're doing it on premise on your cloud, you would run into a lot of issues where either performance is an issue or scalability is an issue because models run on GPUs and GPU scaling is not as mature as CPU scaling in cloud deployment. It's also very expensive. You would run into issues of latency and how to optimize for that and parallelism. And overall, and that's if you are able to find the right model and tool that is robust enough to solve for a use case. We've saw a lot of companies going through a very arduous process of integrating different models and trying to leverage them in their product and not being satisfied or not being consistently satisfied with the results. And I think that creates a lot of friction and concern for product companies And I think as a whole, it hurts the maturity process of language AI in the industry. So the more companies running into difficulties, I've seen companies hiring research teams and working for a very long time only to end up with a project that is not converging to a satisfactory results for no fault of their own, right? Sometimes it's a lack of good enough data, or lack of management attention, or lack of engineering resources, or lack of experience in that specific subdomain, because each domain is extremely sensitive to the way it works. And doing language AI research is different from doing computer vision and other models, and doing content or content classification and categorization is different from identifying complaints in an email which are spams. So each one requires a different specialized skill set and data sets and tooling and platform, and you wouldn't try to build the whole thing from scratch. In many cases, it does not converge to a satisfactory business result, and there are a lot of reasons.
Vast majority of the deployment projects within organization never see the light of production. And it doesn't seem even that it correlates with the number of engineers, ML engineers on the team.
I agree. I think it's not always a question of resources, but a question of experience and domain expertise. And I think companies should stick to their core strengths and win. I think whenever a company, I think there are so many stories of companies diverting from their core strengths and competencies, and paying the price for that.
Let's talk about your AI models that you use to power one AI capabilities. Do you have to build any of them from scratch, or you can find most of you need available as an open source implementation and fine tune from there?
That's one of my favorite questions to talk about, actually, because I wish I could have just found all of the models that we needed in open source repositories or academic papers and just package them and deploy them and just make sure it's all been deployed in highly scalable, performant environment. But that's far from the reality. I think that's one of the key problems we're solving for our customers. Our research teams have the core task to go ahead and solve the problem they're tasks for solving, and by all means necessary. So there's no mandate that we enforce you have to build something from scratch or you cannot build something from scratch. The first step when we're looking at a new use case or a new skill is read all of the academic papers that describe that problem, see all of the work that's already been done, see what data is available out there and what data is available for us in house from our data and from our data teams, and then figuring out what's the best approach to solve the problem in the highest quality and the fastest time to value possible. And then they go ahead and execute. And sometimes that would entail implementing a few academic papers and measuring their output and measure the results. As you know, sometimes the benchmarks reported in academic papers don't necessarily reflect the data that our customers would have in real world in production. In most cases, these data sets do not look like internal business data. Like usually academic research does not involve working through lots of sales calls. They don't have access to that type of information. And that's a big problem, I think, that we're solving for our customers. So we look at the data, we find the best approach, and then as needed, we would go through a research phase that is looking at the actual core fundamental difficulty for why this is not working. And our research teams do have the mandate that whenever they actually do the research, they actually have to come with insights that push the state of the art forward. They have to understand something about the inner workings of the models, that they then apply that new learning to the technology to solve the problem, and not just, trying different hyperparameters and throwing different models on the wall and see what sticks, because that does not help us move faster in the next cycle. So we apply the learning, we Sometimes the learning is, hey, this approach is not the right one. So we need to take a new one, but we need to learn why it wasn't the right approach and what is fundamentally not working in those types of architectures or models or loss functions or whatever system that we use to train these models, and then find the best solution. And that means we're architecture agnostic. I think there is a tendency to use transformers for a lot of the skills because of their power, but it's not exclusive. And in many cases, we would ensemble transformers with other architectures that behave better in specific data, statistics, and different use cases. And we would just find whatever is the best approach for every problem. So we use everything and anything in our availability to solve.
You mentioned that you're trying to push the state of art further. What would be a good example of your team working on that and achieving the next level of quality?
I can give you a few examples. Let's talk about summarization, right? A big problem, open problem that's very hard to measure. And if I'll summarize our podcast right now, it would look a bit different than what you're going to summarize, and very much different than what our listeners would summarize it. Other different people are inclined to see different items as important, and they will definitely phrase themselves differently. So, how do you measure summarization? How do you know that it's working well? And even more importantly, how do you know that the model that generated the summary did not mistake some of the data in it and refer to incorrect numbers or incorrect facts? And that's something we call factual alignment, that the output needs to be factually aligned to the input. It's not necessarily factually correct, because I might say that the Earth is 1.5 billion years old, and I don't actually know the number. And in the summary, we can repeat that it's aligned to the fact as they're mentioned, but definitely not absolutely accurate. So we're factually aligning the summary to the source material. And to do that, there was a whole slew of problems we had to solve for. So first of all, we had to figure out, how do these generative summarization models actually make the decisions of picking information from? And we had a lot of examples where we knew these models are making mistakes. So we had to learn what in the math, what in the architectures of these models make them make these decisions, and how do we know which data point in the origin, the original conversation or podcast, for example, was based on and referred to when generating the summary. And we created a new flavor of generative models that we have interpretability for them. And we know for every different word that they output, what made them make that decision, what data in the source material was the source for that output. And by the way, in our language studio, we highlight all of these sources. And when you summarize text with one AI, we give you, for every piece of the summary, we give you the reference in the origin. We're the only summarization provider that has this capability. And that was a result of the deep research that's been done to make our models factually correct. There was no task to make it interpretable. The interpretability was the way to learn and evolve. And now that we have the interpretability, we can do the factual alignment and also correct these mistakes and tune the way the model generates a summary so it gives us more capabilities.
This is fascinating. Being able to trace the parts of the summary back to the actual origin document is a very powerful thing. You also talk about tailoring the models to different tasks and different domains and making them enterprise ready. How do you approach this, and what kind of challenges you have to overcome?
I think the first challenge is collecting the data sets that we would use to measure whether or not we did a good enough job, or even a step before that, defining the task in a way that's very explicit and very robust, so people can expect the same results regardless of which person we're asking. So if it's a email complaint, define exactly what that is. And then we would collect data. We have various partners we collect data with, and then we label the data. And that's another process. We have an analyst, in-house analyst team that is doing data labeling. We also work with third parties as well to create those data sets that we then define as the benchmark that we would hold ourselves to. It's like test driven development, but for research. We do benchmark driven research. So we first create the benchmark, and then we go on the journey of the research, and we let that dictate where we need to go. And finally, when we have those capabilities in place, there's also always a benchmark that we can say, hey, here's how it's going to look like on your data. And customers are always welcome to try their own data. In our platform, we have a free tier, which is very robust, and you can send a lot of API calls with all of your documents and see the outputs and benchmark it yourself. In many cases, we try to outsource the business benchmarks that we use, and that's an ongoing process for us. Want to empower businesses to understand what to expect from these skills and these capabilities. And the more that we align the value proposition and what is possible to do with the expectations of businesses, customers, and developers, I think we're going to drive faster adoption in higher scale and higher confidence. And ultimately, that's our goal, to bridge the gap between research and, and engineering. And that requires confidence and trust.
Absolutely. Another aspect that you mentioned before is that machine learning models produce statistically probable results, and they're not always accurate. Is it applicable to your models and APIs, and how do you address that? Do you have to implement some guardrails, or is human supervision sufficient?
So I think that's a great question. So there's a fundamental discussion on what machine learning models are. Are they statistical machines that are just correlation descriptors and they just predict the probability of correlations between data points? Or do they model causation, which is the real understanding of the underlying mechanisms that are in play in language? And if we talk to our research teams, they would also start raising questions whether or not human beings really understand causation and not just correlation. And I think that all of the logical fallacies we humans fall into show that we're also not always great at discerning between causation and correlation. It's a very hard thing to do. So if we can understand it well enough, it's very hard for us to teach machines to do it better. But at the end of the day, machine learning represent a mathematical statistical model of the world that we try to make it as robust and explicit enough and put in the guardrails and making it converge to a solution that represents the world as best as possible. And one of the ways to do it is to make sure that the data we're training with and testing with represents the broad spectrum of possibilities. I'll give you an example. One of the skills we're going to be releasing soon is identifying hate speech in social interactions and communications and media. And we had a model that did really, really well in identifying these hate speech remarks. But then our research team was quick to identify that we're also identifying reclaimed speech and mentions of hate speech as hate speech itself. So it created a lot of false positives. So if I would say, hey, we should stop the hate around this or that ethnicity, that basically there's hate speech in it, but I'm not being hateful, I'm just mentioning it. Or even saying that we need to stop it. But that's really confusing for machine learning models because they don't really understand, at least today. So we'll solve that, but it's going to take some time. So we've also went into the trouble of adding a lot of these reclaimed speech and mentions of hate speech into the training and benchmarking of our model to make sure we're doing the right job. So this is part of the job of the research organizations that we have. So it's not only the math, but it's also thinking about the problem and how do we model the problem? What kind of data we need to collect to measure, do we actually solve it? And also force the model to distinguish between those things. Because until we provided these examples that are professionally annotated examples in very high scale, it was impossible for the model to know what we want. So that's part of the process.
And is the data curation also the way to solve another issue with the language models, which is bias?
Data curation is part of the problem of bias, and it's also part of the solution. And I think the more broad data that we can collect and the more customers we're working with allows us to get a bigger presentation of the data our models see. At the end of the day, we only learn what we learn. And the machine learning has an advantage that we can also add more data. Now, the purists will say that's not always true because when you add more data, the model behavior changes. You need to change sometimes the loss or the parameters or the architecture of the model itself. But all things are equal, we can always add more data. And whenever there's an issue, we can fix it. And machine learning models do not hold grudges and they can very easily adapt. And I think we, as a species, we can leverage that. And some it's not perfect yet, right? There are a lot of mistakes and fallacies in models today, even in very large language models. But as we identify them and we improve the ingested data and we adapt the training methodologies, we can get rid of them systematically. And when they're removed for good, especially if you have a few lines in your benchmarks that measure that, which we try to do.
Models don't hold grudges. I like that.
Yeah.
Let's talk about the origins of the idea and the company. What became the trigger to start One AI?
So the team and I have we're all veterans. This is not our first company that we've built, and it's not our first language AI based company that we've built. And coming from that background, and after selling our previous company and figuring out, all right, let's go back to the drawing board and think about what's going to be the next thing. What's going to be the next thing that's going to be really powerful. It's going to be interesting. It's going to provide value, and we're going to be excited for. So we went through ideations of a lot of product ideas and really interesting ones in different domains and verticals in the space of social interactions and customer service and media and sales tech and fintech and all these various ideas. And as we talked to different potential customers and we've talked amongst ourselves, we realized we're going to be building the language AI stack from the ground up for maybe the fourth or fifth time. And every time we've built it, we had to leave the technology in that company, in that use case. So it was only leveraged once. And it was a huge undertaking. And we would have to, we have to, it's a startup. So we have to raise money. We have to work on a tight budget and work fast. And we would have to split our resources between building a language AI tech stack while at the same time building a product tech stack and engineering the UX and going after the customers and product market fit. And that's like building two companies. That's like saying we're going to build our company and we also need to do our own database and our own server infrastructure and our own billing and all of these systems, which is not scalable, right? There's a reason for that. And we thought from all of these other technologies I just mentioned, language AI is the only one we couldn't take platform and build on it and move really fast like a startup should and focus on our business value. And then it hit us that that's what we need to be solving for. That's what we can bring to the world. We can allow companies to focus on their business value while we provide product ready language skills for developers.
How did you go about talking about it and deciding that you all are interested and excited about starting One AI?
I think that was probably the easiest part. So as we went through different ideas and approaches, we were enthusiastic to a degree, and each one of us liked one idea more or the other. And there was a debate. And once we hit this idea, I would say, or this approach and this opportunity, it was, I think, unanimous. We all got immediately excited, and we all just knew that this is the thing that we would be really excited to wake up every morning and not go to sleep every night with, and just make it our lives work.
How do you see the long-term future for One AI? What are your long-term goals for the company?
So we hope to power the world's language AI capabilities. And my goal is to have any developer out there in any product, in any field, just be able to leverage the state of the art in language AI in their product. And that's have always been something I've pursued. So that's always been my goal, to bring language AI capabilities to products. I just didn't know I'm going to be doing that for any product and for other people's products as well, which I think is the great thing that we've started doing in One AI.
This is a much bigger lever now
Yeah,
you have in One AI compared to any other approach you could have taken.
agree.
And for our final question, let's talk about the evolution of AI. What excites and concerns you most there?
Excitements and concerns, I think they're always revolving around the same topics, right? So I think the unexpected outcome of having AI eventually integrated into decision making processes and taking over processes that are traditionally human based, that's something we all need to be cognizant of. It's not something obvious, but instead of being focused on the anxiety part of it or being focused on all of the hype surrounding language AI, we're trying to build it in a way that empowers engineers to control the AI components of different systems. Because if we empower the engineers and give them the tools to tune and control the AI capabilities, we can allow engineers to shape our futures in a way that can only come from really having a deep understanding of these methodologies. I think one of the things I'm seeing, not everywhere, but in many places, that they're brute forcing their way into making AI solve problems without really understanding the underlying difficulties or challenges or issues. So when you find these solutions without really understanding them, we're building layers on top of layers that we don't understand. And finally, when problem is going to arise, especially when AI is going to be integrated into critical systems and into critical decision making systems, it's going to be really hard to fix it. So I think we need to be cognizant as a community, as a research community, on making sure we understand these fundamentals, because sometimes we're rushing to the results. We really want to just get a good paper out with good benchmarks, good numbers. And sometimes it's frustrating not getting those numbers. So you want to brute force your ways into p hacking and just, or hacking your benchmarks, or just throwing some hyper parameters on the problem, or making your language model just extremely huge and hoping for the best. The other approach is to do the work, do it step by step, figuring out why it works, how it works, to the extent possible, and increase the level of human understanding of how the machines work. And I think that eventually that's going to lead to a faster outcome. And it's also going to lead to an outcome that we have better control of.
I think in some sense it's also an education problem. Very few people really understand the capabilities of AI, and what is even more critical, the limitations of the modern AI systems. We can talk about hallucinations and distribution shift and other things. And I think 0.1% of population understand those ideas. Making sure that more people understand, people in business community understand the capabilities and the limitations of the system, I think also a very important step to get to the state you're talking about, where we responsibly leverage AI systems where they're good, and understand that for the other parts, we should continue to leverage either traditional software or human judgment, and never forego either of those things for the novelty or excitement of applying AI to a problem.
Right.
Excellent. Amit, thank you for joining me today. It was a pleasure to talk to you.
It was my pleasure. Thank you for having me.
Thank you for listening. You can check out One AI Language Studio at oneai.com. You can also join One AI community on Discord and follow them on Twitter. The links will be in the show notes.